Hey y'all, it's me, Miss B. Today we are on day 2 of verifying trig identities. Okay, so I want you to go ahead and pause, try this problem on your own, and then we can come back together. I would say start from the left side. I think that's the easiest way to go about it. Okay, so the first thing I would have done is I would have split this into sine of x over sine of x. Oh, that's not sine. Sine of x minus cosine of x over sine of x. So all I did was I split these fractions up. All right, same thing with this fraction, cosine of x over cosine of x minus sine of x over cosine of x. So sine of x over sine of x is equal to 1. Cosine of x over sine of x is equal to cotangent of x. Cosine of x over cosine of x is 1, and sine of x over cosine of x is tangent of x. If we combine these like terms, we get 2 minus cotangent of x minus tangent of x. And we are done because we got what we wanted on the right side. Okay, it may have taken you a little bit longer to think about it, and that's okay. It's just a matter of trying and keep trying on these. Okay, so I just want to remind you the best way to learn is to try it on your own and keep trying it on your own. People telling you what to do isn't going to help you learn how to do it in any way, shape, or form. Okay, so it really is a matter of practicing how to problem solve, because if someone problem solves for you, it doesn't help you. Okay, if you need a hint, always know you can ask for one, but me doing the whole problem for you is not helpful for your learning. Okay, so let's go to our identity sheet and add in the Pythagorean identities. These are also familiar. You're also familiar with these. So we have Pythagorean identities. The most obvious one, or most commonly used, is sine squared x plus cosine squared x equals 1. Our second one is 1 plus cotangent squared x equals cosecant squared x. And then lastly, I'm going to write it. That's fine. We have secant squared x plus 1 equals tangent squared x. Oh, wait, that's not right. Secant squared x plus... I messed that up. So sorry. So this would be tangent squared x plus 1 equals secant squared x. All right, so those are our 3 Pythagorean identities, and we're going to be using those today. All right. So I'm going from 1 to 2 pieces. So I have 1 single fraction to 2 different terms. When I have that, it's pretty obvious, well, at this point to me, but it should be obvious to you at some point that to go from 1 to 2 or from 2 to 1, that means we're going to have a Pythagorean identity. And we're talking about terms. So cotangent squared t is equal to, let's look at our identity sheet. Cotangent, if we subtract 1 from both sides, cotangent squared x is equal to cosecant squared x minus 1. So we can rearrange these equations if we need to. So we have cosecant squared t minus 1 over cosecant t. Again, we are only working from the left side. Then let's separate the fractions. So I have cosecant squared t over cosecant t minus 1 over cosecant t. Just a reminder that cosecant squared t is the same thing as cosecant t quantity squared. So this goes away, as does this, because if it would be like us having an x squared over x, we're left with just an x. In this case, we have cosecant squared over cosecant, so we're just left with cosecant. So I have cosecant t minus 1 over cosecant t. 1 over cosecant t is sine of t, which gives us that we end up with our final answer there. Oh, this is just typo. There should only be one t here. Sorry. Okay, so only one t there. Okay, so we prove that identity. All right, as our problems get longer, more and more we're going to want to keep checking as where we're headed for our goal. So here we used a Pythagorean. Here we used just simplification. Simplify. And then here we use same thing, just simplified. And then we used a reciprocal identity for that last one. Okay. So let's look at this next one here. I would strongly suggest go ahead, pause, try it on your own, and then we'll come back together. Okay, so we have sine squared x minus cosine squared x. A lot of people are going to jump in and they're going to change both at the same time. I would not do that. So here, let's look at what we have. I want cosine because I end up with 2 in the end. So let's not change cosine. Let's instead only change sine of x. So sine squared x, I'm going to use sine squared x plus cosine squared x equals 1. And subtract cosine squared x from both sides. So I get sine squared x equals 1 minus cosine squared x. And I'm just using the identity to get that. So this becomes 1 minus cosine squared x. That's what this is. Minus cosine squared x. Just bringing that down. Okay, so then we have minus cosine squared x minus cosine squared x. That gives me minus 2 cosine squared x's. So that'd be like if I had 1 minus x, I'd get 1 minus 2x. I'm just combining like terms. So I'm even going to write that down. Combine like terms. Our first step, we used a Pythagorean. Okay, and we end up getting exactly what we wanted, 1 minus 2 cosine squared x. Okay, some people may have started in a different place. That's okay. You probably took a little detour, but ended up in the same spot as the rest of us. All right, I would pause and try this next one on your own. Okay, here I just want to give you a little alert. Don't erase what you have. You may have just taken different steps. It's not wrong, it's just different. If you didn't do anything quote unquote illegal, then your work is correct. If you have something different, I am happy to check that work for you. Okay? So I'm going to solve this the easiest way. Okay? So this is quote unquote the easiest way, the one with the least amount of steps. That's the one I'm going to show you. So we know, using the Pythagorean identity, we have 1 plus tangent squared x equals secant squared x. So that's what this is right here. This is equal to secant squared x. So cosine squared x times secant squared x. Okay, so I used a Pythagorean identity there. Secant squared x is equal to 1 over cosine squared x. So that was the reciprocal identity. And then these cancel, and you're left with 1. Okay, so that was just simplification. I'm going to show it another time a different way. All right, as I've told you before, it's good to think about stuff in terms of sine and cosine. So let's go ahead and change this into terms of sine and cosine. So I have cosine squared x times 1 plus sine squared x over cosine squared x. Okay, and to do that, I used a quotient identity. Let's go ahead and distribute this through. So I have cosine squared x plus cosine squared x sine squared x over cosine squared x. These cosines are going to cancel, and I'm left with cosine squared x plus sine squared x. Okay, so that was just, here I used distribution. Then I used simplification. All right, and then cosine squared plus sine squared is equal to 1. That's a Pythagorean identity. Okay, so that was 2 different ways of doing it. I did it in 3 steps, and then I did it in 4 steps. It just depends on how your brain works. I think there are even more ways to do it beyond just that one. Okay, so let's do another one here. Let's do number 5. Okay, so I want to end up with a cosine in the end. So I'm going to start with the left because I have more to work with. But I notice I have a cosine and a cosine, so let's go ahead and factor out that cosine. That's kind of where my mind is going first. So we just factored. Then 1 minus sine squared x, using that sine squared x plus cosine squared x equals 1. If I subtract sine from both sides, then cosine squared x is equal to 1 minus sine squared x. So this whole thing right here is equal to cosine squared x. And so then cosine x times cosine squared x, so that's, we add our exponents and get cosine to the third x, which is what we wanted. Okay, so that's the easiest way to do it. So this was Pythagorean. And then just simplify. Okay, there are other ways of doing that problem. That one is probably the easiest way of doing it. All right, let's see if we got another one here. Number 4 is like number 5. So I don't want to do that one. Number 6 and number 7 are alike. So let's do number 6. For this one, let's get everything in terms of sine and cosine. So get everything into terms of sine and cosine really fast. Do that on your own. So you should have sine of x times sine of x over cosine of x plus cosine of x. Okay. So then I'm going to go ahead and simplify. So we only changed tangent, so we used quotient identity. So I'm going to have sine squared x over cosine of x plus cosine of x. And I'm trying to get to secant. So, and I went from 2 terms to 1 term. So let's go ahead and I'm going to multiply this by cosine of x over cosine of x. So I can get one single fraction. So I have sine squared x over cosine of x plus cosine squared x over cosine of x. And so to do that, all we did was, this was simplifying, and all this was getting a common denominator. Then let's go ahead and add these together. So we have sine squared x plus cosine squared x over cosine of x. So again, that's just simplifying the fractions, adding them together. However, you should notice that sine and cosine together is equal to 1. And so we have that is a Pythagorean identity. Finally, 1 over cosine of x is equal to secant of x using the reciprocal identity. And that is what we wanted at the beginning. So we wanted secant x, we got secant x, so we finished that problem. Okay? Remember, there's not just one way of doing things. There were probably a lot of other ways of solving. Probably a lot of people did it a lot of different ways. I think this one is the easiest for me to wrap my brain around, but other people might think differently. All right, like I said, number 7 is like number 6. We're not doing that. But here, let's go ahead and we'll do number 8 as our last one. So I want you to go ahead and pause and try it on your own. All right. So I'm going to solve this one 2 different ways. I'm going to solve it from the left, and I'm going to solve it from the right. Let's start with the right first, just to switch things up. So let's go ahead and rewrite tangent as sine of x over cosine of x. So then I have sine squared x over cosine of x. All right, then we have a Pythagorean identity because sine squared is equal to 1 minus cosine squared x. That was using a Pythagorean identity. Then let's split that fraction to be 1 over cosine of x minus cosine squared x over cosine of x. That was just fraction work there. And then this is going to cancel with that. So I have 1 over cosine x minus cosine of x. Where am I headed? I want secant minus cosine. And what do you know? 1 over cosine is secant of x. And so we get secant of x minus cosine of x. And that last step we used a reciprocal identity. All right, let's do the left side now. So secant is, let's put all in terms of sine and cosine. So 1 over cosine of x minus cosine of x. Let's get a common denominator here. So I have 1 over cosine x minus cosine squared x over cosine of x. Let's go ahead and combine. So we have 1 minus cosine squared x over cosine of x, that common denominator. And then 1 minus cosine squared is sine squared. See where I'm headed? I need tangent sine. I'm going to go ahead and write that down here. So this is what I'm working for. I can rewrite this as sine of x times sine of x over cosine of x, because that's what squared means. And so then you'll notice that this, or let's actually do it. Yeah, this right here is tangent, and that's sine. So we have tangent of x, sine of x, and we get our final answer there. Okay, so one of those may have made more sense to you than the other. It basically is the same thing, just backwards for that one. Sometimes it doesn't work out that way. But I want you to go ahead, take some time, and finish these other ones. Give them a try. Get started on them at the very least. If you're confused, you can always go back and try these ones that we've already done together on your own and see if you can go through them step by step without any help. That's all for today.